Welcome to Spring LIB.
Hello students, in the first question we have to calculate the heritability. Of obesity for the wild house mice population. So the heritability of obesity for the wild house mice population can be calculated by using the formula, which is heritability is given by the variance in wild population minus variance in inbred population upon the variance in wild population. So as we know that we are being given a heritability H square, variance in wild population is 20 and variance in inbred population is 50 upon 20, which means that 5 upon 20, which is equal to 0.25. So the heritability of obesity for the wild house mice population is 0.025. In another question, we are also supposed to calculate the heritability of tail length in long-tailed widow birds. So to calculate the heritability of tail length in long-tailed widow birds, we can use the formula heritability is equal to the response to selection upon selection differential. So response to selection is equal to the change in average tail length between generations. So which is equal to 39.8 minus 35.8, which are the tail lengths in two different generations, which make the response to selection equal to 4. So response to selection is equal to 4. Now coming to the another component, selection differential. Selection differential is equal to average tail length of the breeding males minus average tail length of entire population, which is equal to 51.8 minus 35.8, because average tail length of the breeding males is 51.8 and average tail length of the entire population is 35.8, which is equal to the 16 centimeters. So we can use this response to selection value 4 and the selection difference 16, which makes the heritability equal to 4 upon 16, which is 0.25. So this heritability of tail length in long-tailed widow birds is 0.25. Another question asked is, what is the phenotypic variance due to the environment of wing length in bat population? So in order to calculate the phenotypic variance due to environment of wing length in the bat population, we can use the formula environmental variance is given by total variance minus the product of heritability times total variance, as the total variance is equal to 22 minus heritability is 0.8 times 22 again for total variance, which is 22 minus 22 minus 17.6, which is 4.4. So the environmental variance is 4.4, which means that the phenotypic variance due to environment of wing length in the bat population is 4.4 centimeter. Another question asked is, what do you expect the average total length of tails in next generation? In order to calculate the expected average total length of the tails in the next generation, we can use the formula response to selection equals heritability times selection differential, as selection differential is equal to average tail length of breeding males minus average tail length of the entire population, which is 92.5 minus 82.5, which is 10 centimeter. So response to selection will be equal to heritability, which is equal to 0.45 times 10, which is equal to 4.5 centimeter. So the expected average tail length in next generation will be current tail length plus response to selection. So the expected tail length, which is current average tail length plus response to selection, current average tail length is 82.5 plus response to selection is 4.5, which makes it equal to 87 centimeter. So the expected average total length of the tails in the next generation will be 87 centimeters. I hope you found the video useful. Thank you.